Okay, guys, so we had a conversation about recursive. Let's now talk about explicit. We're now being asked to find the 50th term in the sequence. Using recursive will be very, not difficult, but time consuming because we would have to continue to add 4, add 4, add 4, add 4, add 4 until we get to the 50th term. It's a good idea to use explicit. So here's the example of explicit. Now, let me write an explicit formula to match this sequence. Well, what's the difference? The difference is still 4. We know that. Okay, that's the difference. What are they asking for here? You're right, they're asking for the first term of the sequence, which happens to be 10. Okay, so this formula matches this sequence. We're done. Now you can use this to find any sequence you want. For instance, if we want to find the 50th term, we're going to make our n equal to 50 because we're trying to find the 50th term. We're trying to find the 50th term. So 50 is our n value. Okay, so now let's simply do the math. 50 minus 1 is 49. Okay. "49 times 4 is 96. And now we're simply adding 10 plus 96, which gives us what? 106. Perfect. Oops. Do you see, because we were looking for the 50th term, we chose to use the explicit, not the recursive. Let's look at one more example. Remember this sequence we looked at earlier? Well, this time they want us to find which term? The 20th term. So once again, I do not want to continue this to find it. I'm not going to use recursive. Instead, I'm going to use explicit. So what do we know about this sequence? Yes, the first term is 5. Super important. We start off with our first term of 5. Okay, now how is this growing? By plus 2, right? So we know our difference is 2. Oops, sorry about that. Do you see? If we want to make it quick, we have to find the 20th term. Instead, we're going to use explicit. First term is 5, and then we see the difference is 2. Now, they did ask specifically for the 20th term. So my n is equal to 20. Let's find the 20th term. If I want to find the 20th term, my n is equal to 20. Okay, let's do the math. 20 minus 1 is 19. We're simplifying now. 19 times 2 is 38. And 38 plus 5 is 43. We have now found the 20th term in this sequence. Isn't that cool? What if they asked for the 101st term? Wow, I'm totally going to use explicit so I don't have to go on forever. So if we want to find the 101st term, my n is now 101. This doesn't change? No way. The first term is still 5. This doesn't change? No way. We still see the difference is 2. But what does change is our n value because we want to find the 101st term. Once again, we simply do the math. 100 minus 1 is 100. 100 times 2 is 200, and 200 plus 5 is 205. Let me fix this so it is indicating the 101st term. Does that make sense? Great. So, to reiterate, when we need to find a term that is pretty far out there, like 101 or 50 or even 20, it's a good idea to use explicit. Remember, explicit requires that you include the first term, which happens to be 5 in this case, and then the difference, which happens to be 2. Okay, I'm going to give you some work on explicit now, and I'm sure you're going to do a fantastic job.